Hey guys, hope you're doing well. I know it's been a while I uploaded a video, but here I am with this new video, and it's going to be a study session where we are going to cover all the API vulnerabilities of OWASP Top 10, and we're going to have a fun CTF challenge to cover all those. So this is a CTF and it is on GitHub named DVAPI, the Vulnerable API. So covers all the OWASP top 10 vulnerabilities, and we have to find a flag and submit a flag for each vulnerability. So it's gonna be really fun. I'm going to provide the timestamps for each vulnerability as well, so you can refer that. Anyways, so here we have the repository, and here we also have a Postman collection. You can clone this and you can use Docker. So as you can see, I started my Docker here, and here I run the command docker compose up build, and it will build this Docker for you. And then it's going to give you this particular URL. It's going to run on localhost on port 3000. Okay, so once you're all set, you will see this page. So here we have all the challenges. And we're going to start with the first challenge, which is broken object level authorization. Before we jump into the challenge, let's understand what are the APIs and how they are working and what parameters they're accepting and everything. So in the repo, you can see this is the DVAPI Postman collection. You can just download this JSON file, and if you open this in your Postman, you can just click on import, and from there you can select the file and import it. It is simple. Now, we have different requests here. First is register, through which you can register a username. So it expects username and password, and this is the API. And then we have the login and profile update. Here you can update your current password. Then you have the profile where you can fetch your own profile information. So this is the response from the previous time I was trying to solve this challenge before recording this. And then here we have this get user, where it fetches a particular user details by the username. And then upload profile pic, where you can upload the profile picture, can log out. Okay, so before you jump into all this, I would suggest you, once you get in here, create an account, and once you're logged in, capture your JWT token in your burp suite. Or you can also copy it from the inspect element like this. Just go to network, reload the page, and over here you can see this is your token. So just copy this whole thing and go to your Postman, click on the DVAPI, and here you can update your token. After you update it, you gotta save it over here. So let me update it. Okay, I didn't copy it. One sec. Paste and save. Okay. So I already registered the account and I got the token, so I don't need to use this register endpoint again. I just have to go to login. Okay. And another way is you can just simply register here and go to login, and then you can get your token from this cookie section over here. There are just two different ways. But the first one is simple, where you can just copy it from the inspect element. Anyways, let's move on to the next one, that is notes. And it has like 3 requests. The first is add notes with link. So you can provide a note here using an external link that you can provide in the URL parameter. Okay, the second one is get note. So you can fetch a note based on the username over here. And then add note. Here you can manually add a note in the note parameter. Okay. Now the third one is challenges. So it basically checks the flags. If you submitted a flag, and it will check if it is correct or not. All challenges fetches all the challenges for you. So you can see there are challenges from 1 to 10. And then get solved. So it checks how many challenges are solved. So currently it should be 0 for everyone because no challenges are solved right now. Let's go to scores, and this one fetches all the scores. For example, you get scores for every flag you submit. So if you submit all the flags, you'll get some amount of scores. So there are some predefined users here like Charlie, Bob, and Alice, and they have solved some of the challenges and their scores are 300, 200. It is in descending order. Okay, and then tickets. So in the submit ticket, you can send a ticket to the application when you need some help, right? And here you can fetch the ticket. Okay, now that we understand what are the functionalities of each API endpoint, we can start testing. So the first one that we need to test for is broken object level authorization. And it says no problem, store a secret node on your profile. So maybe it's related to the secret node. Let's go back to the Postman. Over here, let's go to nodes and get node. Some of you are smart enough and would have realized already that maybe you can try to fetch nodes of other users just based on changing the username here. So let's try something else like Charlie and let's see if we can fetch it. Okay, we can fetch the other users. Let's try admin. Yeah, so we got the first flag. We can fetch the nodes of the other user and we shouldn't be authorized to do so because these are supposed to be secret node. Okay, let's submit the first flag here. Challenge solved. Okay, we got 10 points for this. The second one is broken authentication. Admin has a challenge for you. Admin says anyone who can log in their account will get some surprise. Can you find out the surprise? Okay, so there is some bug in the authentication. Authentication is happening over here in the login endpoint. It means there is something wrong here. We can exploit it. The first thing that comes to mind here is the tokens, the JWT tokens we are provided with. Maybe we can tamper with this one. But first we have to try and decode this token to see how it looks like. So I have configured my burp suite with Postman. You can do that by going to settings and then click on settings and then go to proxy, and there you can set up your proxy server over here and the port number. Once you're done, you'll be able to get to request from your Postman in your burp suite. So if I turn the intercept on and if I send this, you can see I got the request over here. Let me send this to repeater. And this is a JSON web token over here because I downloaded an extension. You can download it from the App Store. It's called JWT editor. Once you go to the JSON web token tab, you can see the decoded value of this JSON web token. And it has 3 parameters: user ID, username, and is admin false. Now I have covered this in my other videos as well. If you see a parameter that says false or true, try to manipulate those values and see if the server accepts that, and if it does, then it's vulnerable. But it's not that easy over here. If you change the value to true and send the request, simple like that, it's saying authentication successful. But if you go to JSON web token, you can see that the is admin value is still false. So it is not accepting our token and we are not the admin. So this is just in disguise. So our goal is to log in as admin, right? So we have to sign a token for admin. That's the logic here. How we can do that? To do that, we have to change some values here. For example, we have to change the username to admin, and then we can try to sign this token. But to sign a JWT token, you need the JWT secret. Now, I have created another video in detail on this as well, how you can find a JWT secret through brute forcing. So To do that, you can use multiple tools like Hashcat or JWT hack. In this video, I'll be using JWT hack to crack the secret. How I can use that, let me show you the GitHub repo for that. If I go over here, here's the repository. Scroll down and you can see you can just simply install this with Go as well. So let me go to my terminal, JWT hack. And you can see the tool is already installed. To find the secret, we have to provide the command like so. First JWT hack, then you have to provide the token. Let's copy it from here. Space. Because we want to crack it, the command goes like this. So crack, then word list. Now you have to get the word list from here. You can find the JWT secrets word list, and you will get it from this GitHub repo. So I'll provide the links in the description. I already have this list downloaded in my sec list, so I'm just going to provide the path here. It was in passwords, or I have to check. Yeah, it's over here. So let me just copy it and paste it here. Now the command is ready, just hit enter. I guess we have to provide these two things first. Let me try. And then the secret. Okay, it's fine if you're not getting the duplicated value here, but this is the command that you can use for cracking the JWT secret. And there is another command that I'm going to use, that is using hashcat. So the command goes like this. I also use hashcat in the previous video that I made on brute forcing the JWT secret. Type hashcat and then you have to provide the mode. So the algorithm is HS356. For that, we're gonna use the command -m 16500. Then -a, and then we have to provide the token. Control C. And then the word list. So it will be user share seclist, and then JWT secret.txt, I guess. Yeah. Okay. Oh yeah, the value of A should be 0. Okay, it's probably because the original value was false in the JWT token, so I'm going to change the value and try to decode it again. So I'm going to remove the initial token. Okay, so now it's cracked. Yeah, because we tampered the value, that's why it's not able to find it. The value of the secret is secret123. So now we have the JWT secret. We can sign the token. Now, how are we gonna do that? To sign the new token, go to Burp Suite and then go to decoder. Paste the correct secret, that is secret123. Then click on encode as base64. Now copy this value and then go to JWT editor. Then click on new symmetric key. Click on generate. Then replace the key value with the secret key we found and click on OK. So now you can use this key to sign any token. Okay, once we have the signing token, let's go to profile. And as we can see, we can fetch our profile here. And it fetches the profile based on the JWT token and whom it belongs to. So we're gonna get this request in the burp first. Now we need to tamper this token. So let's go to JWT token and change this value to admin. And change this to true. And then sign it using the signing key we just created. Then send it. And here we go. We got the flag abusing weak secret. Okay, let's submit this one. And we got 10 more points. Moving on to the third vulnerability, which is broken object property level authorization. It says, I would wish there was a cheat code to top the scoreboard. Okay, so let's go back to the Postman collection, and here we have the scores. We know that we can fetch user's score, and you can see my score right now is 200 because I solved 2 challenges. To top the scoreboard, you have to get the highest score. We have to modify the property score some way without solving the challenge. So how we can do that? We have to analyze the application. So we know that there is a property that exists in the backend. For example, username is a property that exists. So there's another property that exists that is score. So if you go to login, you'll see that accepts username and password to log in a user. But there could be some more parameters as well that it might accept. For example, if you have seen some instances of mass assignment where you can add another parameter like this is admin, and then you can assign it value like true, and it will give you admin privileges. So you are basically assigning a property and giving it a value, and you're updating that property in the backend. Obviously, you're not allowed or authorized to do so, but if the application is not checking if the user is allowed to update that property directly or not, then it's vulnerable. So we have to see how we can update that. To update something, you need to perform a post request. Now, let's see if we can assign our solved score while we register a user, or if we try to log in. It's most likely could be in the register, because whenever you register a new user, that's where you try to modify the pre-existing properties. So let's do one thing. We already have this username and password here. We're going to add another, that is score. And I'm going to give this value 10,000. Let's give more zeros. Okay. So now we have this score. And let's see if we are able to register the user with this. Okay, it says registration successful, but we're still not confirmed. Okay, so let's go to login, but let me copy this. Login. And then we paste it over here. Send. And it provided me a token. Let's copy this token and update the token value over here. Save. And now let's go to scores and let's see if we have a user named ABC who has score. And over here we can see that the ABC user is added and it does have a huge score, means the property we saw can be updated. And here we have the flag as well. So what just happened is, if you are analyzing APIs, you need to look out for all the parameters. For example, API/score endpoint, we found out that, okay, there is one more property here that is score, and it has a numerical value. Now this score is assigned to you by the server, but you can also check if you can assign yourself something. But you can also check if you can assign that score to yourself. It could be anything. As I said, it could be is admin. You can assign yourself admin privileges like that, because there is no authorization check. So always look out for those properties by analyzing the APIs. Let's submit the flag here. Okay, solved. Now let's move to unrestricted resource consumption. What's unrestricted resource consumption? This basically are the type of vulnerabilities where you can try to overflood the API, for example, like brute forcing, because it doesn't have any rate limiting. So cases where you can try different kinds of OTPs, or cases where you can send a large amount of requests when you're brute forcing username or password. So there should be some limit on those endpoints, because what happens is, if an API is accepting a lot of requests, if a lot of traffic is going through those APIs, then it's also going to increase the cost for the organization as well, because it depends on how much the API is being consumed, and according to that the cost is set. Now if you click on read more, you can see some description. It says API requests consume resources such as CPU, memory, bandwidth, storage, and integration with other services. Now, attacker can cause high resource consumption by sending excessive requests, leading to unresponsive APIs or increased business expenses. Okay, so we have to find an API endpoint where we can perform this kind of attack. Okay, let's go back to the Postman collection. Now think where you can exploit this vulnerability. Think what kind of endpoint can increase the memory storage or the CPU bandwidth. Here we have the endpoint that is API profile upload. So in this case, we can try to upload a very large image. The image are supposed to be in KBs or MB, could be 1 or 2, but mostly KBs. But if you are able to upload a huge file that in thousands of MBs or something, then it is definitely not acceptable. It's going to increase the bandwidth and the storage as well. So in this case, you have to take any image and try to increase its size. How you can do that is, I can suggest you a tool that is pre-installed in Linux. Go to Google and search for file size increase dd command. Now you can find some online tools as well that can increase the file size, but I tried those and they didn't increase as much as we wanted, so I'm going to use this tool. As you can see, it says the dd command can be used to create, clone, or overwrite image files, including large ones. So there is a particular command, this one, that can increase the size of an image file. Okay, so Control C. I'm going to move on to the particular path where I have image files. You can choose any image file, and I'm going to type the size here, size in megabytes it's asking for. So let's say 1000, and here we have to provide the name of the file. In my case, it's medusa.jpg. Hit enter. Okay, and here we have the file. It's increased to 1000 megabytes now. It doesn't create a new file for you, it will just increase the size of the existing file. So the name will be same. We can go back to Postman collection, and from here select the file that we want to upload. So I'm going to click on new file from local machine, and then medusa.jpg, open it up, and then send. As you can see, it's taking time to send the request because it's a huge file. Okay, I think 1000 is a bit too much. So I'm going to decrease the size because it's taking a lot of time. Let's say 60. But 60 MB is pretty huge as well. So let's change it again. Okay, now it says 63 MB now. Let's try to re-upload the file. Because this is a CTF challenge, it's expecting some particular size of file to give you the flag. So I guess if you go less than 60, it won't give you the flag. And you can see, here we have it. File size is important. Okay, so let's submit this one. Okay, let's move on to the fifth one, broken function level authorization. Or you can also call it broken functionality level authorization. So, in this vulnerability, you are able to perform specific functions on API object, which you are not allowed to do so. And some of these functions are restricted to certain user permissions. As you can see, it says it is crucial to implement proper authorization checks for API functions to ensure users are granted the correct privileges for object manipulation. Okay, let's go to the collection. For here, this function took my interest. Get user. Fetch the user details. For example, if I type my own username, I'll be able to get my own details. The score, username, profile pic, unsolved. Now let's see if we can get these details for admin. Yep, we can. Note is we are just performing a get operation right now, which is to fetch something. Since this vulnerability is broken function, means we have to perform something, an operation, and when you have to perform something like update, delete, you gotta try different HTTP methods like post or delete. So if we had something that we are not allowed to add, we will use post request. But we can also try something, let's say if we can delete another user. So here I'm going to change the HTTP method to delete, and in this endpoint I'm going to send this request for another user, let's say Charlie. I know this user exists, and let's see if it works. It works. So we were able to delete the Charlie user. So this particular delete operation was supposed to be restricted to admins only, but it is not checking my permissions properly in the backend. That's why I'm able to perform this operation. Let's copy it and provide the flag here. Okay, moving on to the sixth one, that is unrestricted access to sensitive business flows. Let's read more about it. Unrestricted access to sensitive business flows is a critical vulnerability that enables attackers to exploit APIs by gaining excessive access to sensitive business processes. Okay, so means you are able to get access to those functions that are supposed to be sensitive and are allowed to be used less. Here they have provided a really good example. It says, as a quick example of this vulnerability, consider an e-commerce application that is about to run a flash sale where a limited amount of an exclusive item is sold. Customers eagerly wait for the sale to start. When the sale starts, an attacker uses an automated script to quickly order all the items on the sale. Yeah, so this is limited and this was not allowed to do so because it is a sensitive business flow. Now, using this opportunity of scarcity of the exclusive products, they resell at higher prices to make a profit. And that makes it a vulnerability, unrestricted access to business flows. Sensitive business flows. Okay, so we have to find an API endpoint that is supposed to be sensitive and should be limited. So in this case, what it could be? In this case, it's the ticket. So when you have a problem, you are supposed to submit a ticket. Now you can submit ticket once or twice, but it has to be limited, right? But what if a single user is about to send thousands of tickets? And that is not normal. So in this case, you can see that the endpoint is /API/add ticket, and I can add a ticket using the post_HTTP method here. To exploit this vulnerability, we have to send excessive amount of request. To do that, I'm going to capture this request in intercept and click on send. And I'm going to send this request to intruder. I know intruder is slow, but for this, we don't want too much request. Some 100 payloads should work. Okay, let's close this thing. So we want to send this request multiple times, but we don't want to modify anything. For that, you can just click on null payloads, and then here you can provide payloads like 100, and then click on start attack. And it's going to take a little time, but not too much. Okay, let's start filtering out the response or the length. Okay, we got the flag. So the response received in this one is 21, which is more. Let's copy this. And we can stop the attack now. Because there was no rate limit, it was vulnerable. Now, let's move on to the 7th one, that is server-side request forgery. Pretty sure a lot of people must have noticed the endpoint that we were analyzing in the start, the one that has the URL parameter in notes. This one, add note with link, means you can provide an external link that will fetch the note for you. Okay, if it is not sanitizing the input, we can try to fetch some internal information by using port scanning. To perform port scanning, you have to fuzz through different port numbers. So basically, we are going to fuzz here and everything will remain the same. For that, I'm going to use fuff because fuff is more faster. And for that, we have to create a proper command. So open up the terminal. And I'm going to move here. I do have one word list that I created for port numbers. It was, this one, ports list.txt. You can generate one as well through ChatGPT. It shouldn't be too hard. Just start from 0 to 65535 ports. Okay, now let's type in the command here. I don't really want to waste your time typing in the command manually, so I'm just going to paste the command that I made in my notes, which is this. So first you provide the FUF command, then you provide the HTTP method, that is post, and then you provide the URL, and then the content type and other headers. If you don't provide this header, it will still work, but then you have to provide this header for sure. So this is the authorization header, and we have to change this. Now everything is done. Provide the word list, ports list.txt, and here we want to fuzz for ports. Everything looks good. Now let's enter. Okay, we have to filter code 200. Now hit enter. Whoa, it didn't filter the code. Now we found one port that is 3000, and it's the normal one in which the application is running on. Let's wait a bit more. Okay, we found another port, 8443. Let's try this out. Change the port to 8443 and then send the request. And here we got the flag for SSRF. So we were able to do port scanning through SSRF here because there is no validation for this URL value in the backend. We can stop this attack here and go to submit the flag. Okay, now let's move on to the 8th, which is security misconfiguration. The developers at DVAPI are lazy, which has led to a misconfigured system. Find the misconfiguration and submit the flag. Okay, so there is some misconfiguration on what it could be. Let's read a bit more. Some forms of security misconfiguration are not changing default passwords, not patching systems with security updates, leaving unnecessary ports open, or giving a sensitive information in errors. We can try a few things. We can try if unnecessary ports are open, which we already did, but that is for SSRF, so that is out of the picture. We can try to generate an error by submitting wrong token. I'm going to remove the number 8 here and save this. So now this token is invalid. Now let's try to fetch the profile details from the API profile endpoint, and it's giving me an error. If I scroll down, you can see the server misconfiguration flag, stack trace error. Okay, let's copy it and submit the flag. Now only 2 flags are left. The 9th one is improper inventory management. There was a data leak at DVAPI. People found out there are 12 challenges and not 10. What do you think? What's going on here? Let's read a bit more. Asset management is all about keeping track of what you have, what you need, and when you need it. When it comes to APIs, improper inventory management can mean not keeping track of all the APIs in use, their access levels, or who has access to them. So we have to find an API that is providing access to something we are not allowed to see. It could be being able to use the old version of the API. I mean, you have seen those instances, let's say /API/version1/profile. Now, this is the older version, and let's say the developers thought to switch to version 2 and change the endpoint to /API version 2/profile. Now this is the version that everyone is using, but they forgot to discard the previous version. Now if you're still able to see the previous version, then it's vulnerable. So this vulnerability is similar to that. So we have to find an API endpoint that is doing something similar. So it's about the challenges, right? There are up to 10 challenges, it says. So there must be vulnerability in the challenges one. So here we can fetch all the challenges that are from 1 to 10. Okay, let me change the token back to normal. It was 8. Now back to the challenges endpoint. And here we can see all the challenges here. And the parameter that has value 1. Now we can try changing it to 2 and we can see if we get something, but it says error. So if it says release, we can try something like unreleased and send the request. Okay, we got 2 more challenges, 11 and 12. These are the challenges that are supposed to be unreleased. So here we get the flag. As I said, if you see keywords like version, released, staging, you can try manipulating with the values and check how the API is responding. If you want to read more about it, I would suggest you to look at the OWASP API top 10 document, and there you'll see more examples and case scenarios. Now this is the last one, and it definitely took me time as well to solve it. So this is the unsafe consumption of APIs. It says API is used at the authentication of the application does not look safe. Can you test it to get the flag? So there is a vulnerability in the login endpoint, pretty sure. But what could be the vulnerability here? Let's click on read more. Developers tend to trust data received from the third-party APIs more than user input. This is especially true if the API is offered by the well-known companies. Because of that, developers tend to adopt weaker security standards, for instance, in regards to input validation and sanitization. Now, there are 3 things that you wanna focus on. 3 keywords, that is third-party APIs, second is input validation, and third is input sanitization. Now, because we are hosting this on a local host, pretty sure we're not going to use third-party or exploiting third-party APIs to get the flag. So that is out of the picture. What we are left with is input validation and sanitization. So it could be injection attacks. Now, obviously this application is using a particular server or database in the backend to fetch those flags. So you have to find what database it is using. If you click at the Vapalizer, it says it doesn't give you much information. Now, in cases like this, what you want to do is to try different kind of SQL payloads or no SQL payloads to see how the endpoint is responding, which I did. I tried the SQL injection, but it didn't work. So I tried some non-SQL injection. I also looked at the backend code. And when I was going through the source code, let me show you. If you go to models, you'll see a file db.js, and if you open that file, you'll see that it is using MongoDB. Means there is MongoDB no SQL injection here, but I tried some of the payloads and it was still not working. So I did a bit more research. I found out about this vulnerability called MongoDB object injection, and it occurs when the attacker is able to manipulate the data that is passed into the MongoDB queries, allowing them to execute arbitrary queries or alter the application's behavior. I came across this resource that talks about NoSQL-like query object injection and specific in MongoDB. So here you can see the types of input that MongoDB expects is binary and query object. In this case, this is the syntax, and the syntax in the backend of this challenge is pretty similar, which I'll show you in a few minutes. So it says query object can be leveraged to validate the username and password. In this case, you can set the password value to another query object. And here, $exist is a query object. Also, you can call it a query operator, and this will result in either a true or a false condition. And because it is checking for both the specified query to be true, it's an AND query. And since the username is admin exists the backend and the password for the admin exists as well, it will give the condition as true, and it will lead to the bypass of login authentication. Now, there are multiple kinds of query operators, not just that. There are some comparison operators as well and some logical operators as well. But this one is pretty simple, so we're going to try this one. I'll provide the link in the description of this resource. You can do a little bit more research on that. Let's first capture the request from the postman. And over here, we're going to try the query. So it goes like this. Curly braces, inside the curly braces, double quotes, and over there you're going to type exist, and then you're going to give its value true. Okay, internal server error, this is weird. Okay, I realize we're getting this because the syntax is wrong. There has to be $1 here. Okay, now this is perfectly working. And we got the last flag here, no SQLi pawn. So if you look at the backend, I think it's here. It's in the auth.js. So if you scroll down, here is the login function, and here we have the username and password. So this one finds the user with the given username and password. Okay, so let's submit the last flag. Okay, all the challenges are solved. Now, I would really suggest you guys to try out this challenge. It was really fun. And you can also look at the OWASP API top 10 and read some of the documents about it as well. It was really fun doing these challenges and making a video on this as well for you guys. Let me know your views in the comment section, and if you have any questions related to any vulnerability or you're confused, you can just drop your comment below. Thank you for watching, and I'll see you in the next one.